As we continue our discussion of integration, let's now talk about the general power rule. One of the important parts of this general power rule is to know when to use it. If I have ax plus b to the n, you have to have a function in this form. A constant times x to the, notice this is x to the 1 power, to the first power, plus b raised to some power n. Well, there's a little trick here. Of course it's going to be ax plus b to the n plus 1 divided by n plus 1. That should make sense because we are integrating, add and divide. But the extra little step is that you've got to also multiply by, it's the coefficient of your x term, a, down here, and it's the indefinite integral, so we're adding our constant of integration. Note that for this, n cannot equal negative 1. Why? What happens when we have negative 1 for our exponent? When we have that situation, it's almost like we can think of it as 1 over x to the 1. And we know when we integrate 1 over x to the 1, that involves natural logs. So if I have this situation here, integrating 1 over, again, a constant times x to the first power, this is considered an exponent of negative 1 because it's down in the denominator. So, of course, 1 over x would give us natural log of x plus c. Well, we don't have just x, we have ax plus b, and the one extra step is, again, we have a multiplying by x to the first power. We're going to have to divide now by 1 over a. So it's super important to know these rules and know when to use them. When you have ax plus b, constant and constant in the parentheses raised to some other power, provided it's not negative 1, then you use this rule. Remember, we have to divide not only by n plus 1, but multiply that by a. And here, you have to recognize that this is sort of like 1 over x. That's going to give us natural log of whatever's in parentheses times 1 over the coefficient of the x. In our last example, we talked about the general power rule. The antiderivative, or the integral of ax plus b to the n is ax plus b to the n plus 1 divided by a times n plus 1. Right here. Plus c. And we saw that in this case, n cannot equal negative 1. And here, when x does equal negative 1, we're going to go to natural log ax plus b times 1 over a. Remember, when we take the integral, we're thinking we have to divide. We're going to have to divide. It's sort of the, I call it the opposite of the chain rule almost. Well, we know the integral of sine is negative cosine of what? Ax plus b plus the constant of integration. Well, here we have x to the first power, and there's some coefficient there. We have to divide by that coefficient. So sine ax plus b goes to negative 1 over a cosine ax plus b plus c. The integral of cosine, of course, is sine ax plus b plus c, the constant of integration. Now we're taking the integral, and we have to divide by a, or multiply by 1 over a. The integral of secant squared is tangent. Tangent of what? Tangent ax plus b plus the constant of integration times 1 over a, or you could think of it as divided by the coefficient of whatever's multiplying by your x, provided the x is to the first power there. And last but not least, the antiderivative, or the integral of e to something is going to be e to that same thing, ax plus b, plus the constant of integration, times 1 over the coefficient of your x. So you have to know these by heart. You have to know these. Before we move on, you have to make sure you know these. Now let's apply them to some examples. Here are a couple of examples of using the general power rule of integration. For example, take the integral of 4x plus 3 to the 6th dx. You have to recognize that that is really ax plus b to the n dx, and we're taking the integral of that. And once you recognize that that is the pattern, you can apply the rule. All right, so what does it mean? If that's our pattern, then we can say, well, this is going to be 4x plus 3 to the n is 6 plus 1 is 7 divided by 7 times the coefficient of what was there. So we'll wind up with 4x plus 3 to the 7th power, all divided by 28, plus the constant of integration. Here, in this case, you'd have to recognize that we have 1 over ax plus b dx, and we're going to integrate that, which of course should bring to your mind that you're going to have to use natural logs. Well, we have to know the rule for natural logs. That's going to be natural log of whatever's in parentheses, because it's ax plus b. We can't do it if it's squared or it's cubed, but this is to the first power, so the rule applies. 2x plus 4 divided by whatever your coefficient was there, 2 plus the constant of integration. Using the rules that we talked about earlier in the lesson, I would hope that these problems would be relatively simple. You have to recognize that this is the integral of sine ax plus b. Again, it's x to the first power, which will give you negative cosine 5x plus 2 plus c times 1 over 5, which is the coefficient of the x. Here you could recognize that cosine x over 4 could be written as cosine 1/4 x minus 1. Once you see that that's cosine 1/4 x minus 1, it becomes clear that this should be sine x over 4 minus 1 plus c divided by 1 divided by 1/4, which is the same as saying 1 over 1/4 is really the same as saying times 4 out in front. Over here we have secant squared 2x plus 3. Recognize that it's really the integral of secant squared ax plus b. So that's going to give us tangent 2x plus 3 plus c times 1 over 2, or divided by 2. And last but not least, e to the 5x minus 1 is really e to the ax plus b, where b is a negative 1. So that's going to give us e to the 5x minus 1 plus c times 1 over 5. These are very easy examples, but you have to be automatic with these so that when you see harder problems, the easier parts of the harder problems come naturally to you.